So today we're going to look at factoring quadratics. So in our last lesson, we looked at graphing and then solving quadratics by graphing. But we did look at one last example that showed us that there are some limitations when we're solving by graphing. If we're not getting whole numbers, then the solving by graphing is not really going to be a good option because we could plug numbers in all day long and still not find the answer. So just like with our systems of equations, we need another option. We need a algebraic option that will allow us to solve quadratics. And so we do have that, and one of our options is called factoring. So the big thing that we're going to be using is called our zero product property. And it states for any real numbers, a and b, if a times b equals 0, then either a equals 0, b equals 0, or both a and b equals 0. And this is helpful because if we can break apart our quadratic, so remember that's a degree of 2, into something that looks like our example, so x plus 3 times x plus 5 equals 0, we can set each of those factors equal to 0 separately and then solve. And those are just linear equations, and we know how to solve this. So the process of getting our quadratic to look like the two factors that we have here is called factoring. And we have two kind of main methods that we're going to look at. So the first example that we want to look at, we have 16x squared plus 8x equals 0. So the first thing that we always want to check for is the GCF. And hopefully we've seen this before. If we haven't, this stands for the greatest common factor. And we want to use this and factor it out because sometimes it will allow us to get that multiplication that we need. So hopefully we remember the greatest common factors of two numbers is pretty easy to find. It's just a number that goes into both of them. And because it's the greatest common factor, we want it to be the biggest number that goes into both of them. So notice like for 16 and 8, 2 goes into both of those. 4 goes into both of those. But we want to pick the biggest or the greatest common factor. And so we want to pick 8 because 8 goes into both 16 and it goes into itself. And then we have two variables. We have x squared and we have x. So notice that they have a common theme or variable of x, but we can only pull out the smallest exponent of that variable that we have. So we're only going to be able to factor out or pull out an x. So we can kind of think of like a factoring like division. And so instead of dividing both sides, what we're going to do is we're going to divide it out to the front. And what I mean by front is we're going to put a big parentheses there. So then, like I said, we can think of it like division. So we have 16x squared divided by 8x is going to give me a 2x left on the inside. And then 8x divided by 8x gives us 1. So the 8x doesn't just go away. We have to put a placeholder of 1 there. Otherwise, if we multiplied it back out, we wouldn't get what we started with. So now notice that this looks like those two factors that we had on the previous page. They're separated by multiplication. So now I know that either 8x is going to have to equal 0 or 2x plus 1 is going to have to equal 0. And so what we can do from there is once I set both of my linear equations equal to 0, we can just solve. So we know that I divide both sides by 8 and I get 0. Then we would subtract 1, divide by 2, and we get that x equals negative 1/2. So this tells us that my quadratic has two solutions, negative 1/2 and 0. So as long as we can get that equation, quadratic, broken apart into two factors, we can solve it. And we will be looking at a few other methods that aren't the GCF that will help us be able to break it apart.